Okay, this is section 5.4, and we officially get to this thing called the complex conjugate. I've mentioned it already a couple of times. And if we have z equals x plus iy, its conjugate, z bar, is x minus iy. And I already mentioned in the geometry that it's the two are reflections over the real axis, and they have a number of properties that are pretty straightforward to show. So, for instance, one property is that the conjugate of a sum is just the sum of the conjugates. And, if you're proving something like that, right, you start with that, which, okay, so we would have, if z1 and z2 were x1 plus iy1 and x2 plus iy2, then the sum is x1 plus x2 plus I times y1 plus y2, like that. And we want that conjugate, but if I want that conjugate, that's x1 plus x2 minus I times y1 plus y2. And now I just split everything up, and I have my x1 minus I y1 plus x2 minus I y2. And then that is x1 plus I y1 conjugate and plus x2 minus I plus I y2 conjugate. And so there's my z1 conjugate plus z2 conjugate. So that's, the idea in most of these proofs. So a second property is the conjugate of minus z is equal to minus the conjugate of z. So that's kind of nice. They do z1 minus z2 then. That's just conjugate of z1 minus the conjugate of z2. If I multiply two complex numbers and then take the conjugate, I could have done the conjugate first on each one and then multiplied, so that's nice. If I'm taking 1 over z and I take that conjugate, then that's just the same thing as 1 over z conjugate. So it can, this conjugate gets moved around pretty well in all this stuff. Z2 conjugate, and that again is just each one separately. I can do it that way. So we have all those. Do they have more? Yes, they have a couple more. So 7. If z is real, okay, or z, they say z is real, if and only if, so that's an if and only if, z conjugate is equal to z. And 8, if I want to get the real part of z, I can simply take z plus z conjugate over 2, and if I would like to get the imaginary part of z, I can just take z minus z conjugate over 2I. Okay, because if I'm trying to get at the imaginary part, all right, I will have an I stuck in there, but the imaginary part of z, remember, is a real number, and that's why we're dividing by I there. And then 9, if z equals x plus iy, then z times z conjugate is x squared plus y squared. That's a very nice property right there. So that's just the conjugate and a bunch of its properties. We'll stop this video here and then do more with the theorems.